In this example, I will demonstrate how to simplify an expression using the properties of exponents. So before you watch this video, make sure you've read the text and you know all the properties of exponents. So in the instructions, it says here that we need to simplify, and we need to write our answer with only positive exponents, which I went ahead and highlighted. So there are two important things about reading the instructions. Number one, it tells you what to do. Number two, sometimes it will tell you how to write your answer. And in this case, your answer is only acceptable if it has positive exponents. Okay, so I have a part A and a part B, so we're going to work out two examples. In part A, we have a fraction. So what I'm going to do is simplify the numerator and denominator separately before I start combining terms across the division bar here. I'm also going to work out these examples from top to bottom. I'm going to show my work vertically. It's a nice way to organize your notes so it's easy for you to read and for your instructor to read. So for part A, I see that I have some parentheses here, and this entire quantity is being raised to the power -3. So I'm going to use one of the properties of exponents that says if I have a product raised to a power, then that power can be applied to each factor in the product. So I'm going to write an equal sign because I'm making an expression that is equal to this. I have my division bar. I'm not doing anything with the denominator right now or the -9 to the 0. What I am messing with is this quantity right here. So that's what I'm changing. I'm going to have x squared to the -3rd and y squared to the -3rd. So this exponent can be applied to each factor in this product. Okay, so notice my use of parentheses, really important. Make sure you use those. Okay, so now I now have even more parentheses, so I need to address those. If I have, let's look at this x term, a base raised to a power raised to another power, we have a property for that as well. So again, I'm going to write an equal sign, copy down my division bar, and everything else that I'm not working with right now. So base raised to a power to another power, I can combine the exponents by multiplication. So I'm going to have x to the -6th power because 2 times -3 is -6. Similarly, right here I have base to a power to another power. I'll use the same property here. So what you often see in math texts, and it's a really good thing to do in your notes, especially when you're first learning something, is to write off to the side what you did in that step. So how I got from the given problem, step 0, to step 1, is I used the property that a product raised to a power is equal to each factor in that product being raised to that power. And then to go from this step to this step, we use the property that a base raised to a power raised to another power is really just the base raised to the product of those two powers. Great. This way, when you go back through your notes and you're wondering, how on earth did I go from here to there? It's because of this reason. Okay, so I've eliminated the parentheses, which is super useful. I have a constant, an x term, and a y term in the numerator. I have a constant x term and y term in the denominator. However, this constant term right here could use some simplifying, -9 to the 0. So I'm going to work on that term. Okay, so -9 to the 0, one thing you need to notice here is that there are no parentheses, which is a big difference from -9 to the 0 with parentheses. So because there are no parentheses around -9, just 9 is being raised to the power 0. So what I'm going to do is use the property that any base raised to the power 0 is 1. So this is a -1. 9 to the 0 is 1, and it's negative. Okay, so now what we're going to do is combine like factors across this division bar. So constants or coefficients, x's and y's. So what I'm going to do is use the quotient rule. So I'm going to use the property that if you have the same base in the numerator and denominator, but they're raised to different powers, then you can combine them together in the numerator as that base raised to the difference in the two powers. And notice the order of this subtraction, that's really important. Okay, so I have a -1/3, which I'll leave as a -1/3. X to the -6, x to the -4 can be combined together as x to the -6 minus -4. And then y in the numerator and denominator can be combined together as y to the -6 minus 1, because there's an invisible exponent of 1 right here. Okay, so now I'll actually, do this subtraction here. So -6 minus -4 is the same as -6 plus 4, which is -2. -6 minus 1 is a -7. Now I can't write my answer with negative exponents, so I'm going to use the property that says a base raised to a negative exponent is the same as 1 over the base to the positive exponent. So equals -1 in the numerator divided by 3 is in the denominator. So now we're going to change our negative exponents to be positive in the denominator. So x squared and y to the 7th. And that right there is my final answer. So for the second example, over here I'm going to draw a line to separate my work. Here I'm not starting out with a quotient. I just have all of this in the numerator. So there is no division bar. But that's fine. I'm going to work with these parentheses here because all of these factors are being raised to the power -2. I'm going to use the same property I used right here. Because I have a product to a power, each factor in that product can be raised to that power. So I'm going to do that here. Again, notice my use of parentheses. All of x to the 5th is being raised to the -2. The last thing that you want is to make it look like subtraction is occurring in that exponent if that's not really what you want. Okay, so each of these factors, these are all being multiplied. So I'd like to eliminate each set of parentheses here using the same property written right here. Base to a power to another power, I can combine the exponents using multiplication. So this is 4 to the power 4, x to the power -10, y to the power 6, and z to the power -8. Okay, so I need to simplify 4 to the 4th. I need to actually multiply this out. Also, I can't have negative exponents. Again, only positive are allowed in my final answer. So remember that exponents are just repeated multiplication. So off to the side, 4 times 4 times 4 times 4 is really what this is saying. And I know 4 times 4 is 16. So I need to know what 16 times 16 is. And at this point, I might get out my calculator. 16 times 16 is 256. So 4 to the 4th is 256. X to the negative 10. Again, I'm going to use this property right here to take care of my negative exponent and write it using a positive. So that x term is now going to live in the denominator, and it will have a positive 10 as an exponent. Y to the 6th is already perfect, so that will stay in the numerator. And then z to the negative 8, again a negative exponent. So that will come down here in the denominator, making the exponent positive. I only have a single x, a single y, a single z, and a single number. This answer is completely finished. Circle it and move on to the next problem.